Ever wondered how rivers shape our world? Welcome to Class Bites. Today, we're diving into the fascinating science of fluvial geomorphology and the powerful ways water sculpts the land. The story of the land is often written in water. Fluvial geomorphology is the language we use to read that story, a field dedicated to understanding the intricate dance between rivers and the landscapes they carve. It is a tale of creation and change, where flowing water acts as both a powerful sculptor and a patient builder. A river is not merely a channel of water, but a complex, living system, where the volume of its flow, the burden of sediment it carries, the steepness of its path, and the very ground it touches all conspire to shape its form and behavior. This grand narrative unfolds in three acts: the relentless taking away of material, the steady journey of that material downstream, and the final gentle act of giving it back to the land. The river's journey begins in the headwaters, high in the watershed, where its energy is greatest and its primary purpose is to dismantle the earth. This is the realm of erosion, a process that unfolds through four distinct methods. First is the brute force of hydraulic action, where the sheer power of the moving water pries away loose particles from the riverbed and its banks, a constant percussive force that loosens the foundations of the landscape. The river then uses the very tools it has just acquired in a process called abrasion or corrosion. Here, the sediment it carries, from tiny grains of sand to larger pebbles, acts like sandpaper, grinding and scraping against the channel, wearing it down and widening its path. As these rocky tools are used, they too are changed. Attrition is the sound of the river's cargo colliding in the current, a chaotic tumbling where sharp edges are smoothed and large rocks are broken into smaller, more rounded pieces. Finally, there is the quiet, almost invisible work of corrosion or solution. The river's water, being slightly acidic, can slowly dissolve certain types of rock, chemically weathering the landscape and carrying away soluble minerals as an unseen passenger. Once the river has gathered its load of sediment, the second act begins: transportation. The river becomes a great conveyor, moving its collection of earth downstream toward its ultimate destination. The heaviest materials, like boulders and large cobbles, are often too weighty to be lifted. Instead, they are pushed and rolled along the riverbed in a slow, powerful process known as traction, a method most apparent when the river is swollen with high flows. Smaller, lighter particles like sand and gravel are moved in a more energetic fashion. They are lifted from the bed by the current, carried a short distance, and then dropped, only to be picked up again in a hopping, skipping motion called saltation. Even finer materials, such as silt and clay, are so light that they become part of the suspended load, held aloft within the water itself, giving the river its often murky or cloudy appearance. The last part of the river's cargo is the dissolved load, the minerals taken by solution, which travel invisibly within the water, a hidden contribution to the river's transformative power. The river's path is not a random scrawl upon the land, but part of a larger, organized network. These drainage systems, the patterns formed by countless streams and rivers, are dictated by the world they flow through. Their design is governed by the topography, the steepness of the slope, and whether the underlying rock is hard and resistant or soft and yielding. When a river system's pattern harmonizes with the structure and relief of the landscape, it is called accordant, flowing in a way that seems logical and expected. However, some systems are discordant, cutting across the grain of the land in defiance of the underlying geology and topography, their paths telling a more complex geological history. As the river's journey progresses, it moves from the steep headwaters into the flatter, middle, and lower reaches. Here, its energy begins to wane, setting the stage for the final act: deposition. When the river's velocity decreases, it can no longer carry the heavy burden it has transported from upstream. This slowing happens for many reasons: a gentler gradient, the inside bend of a curve, or its arrival at a vast, still body of water like a lake or an ocean. As it slows, it begins to drop its sediment, a process of giving back what it once took. This deposited material, a mixture of gravel, sand, silt, and clay, is known collectively as alluvium. Over immense spans of time, this process builds new landforms. The flat area adjacent to the river, known as the floodplain, is built layer by layer from the sediment left behind when the river overflows its banks during floods. These same floods can also build up ridges of sediment directly along the channel, creating natural levees. In these lower, flatter lands, the river often meanders in wide, looping curves. As it flows around a bend, it erodes the outer bank while depositing sediment on the slower inner bank, exaggerating the curve over time. Eventually, the river may become so unstable that it seeks a more direct route, cutting across the narrow neck of land in the meander loop. The old abandoned channel is left behind, a crescent-shaped body of water called an Oxbow lake, a silent testament to the river's ever-changing course and its unending power to shape the world. Thanks for watching. Please like, subscribe, and comment below with your thoughts or what you'd like to see next.